Hi, hello. I'm going to show you how to integrate LangChain4j with mcp.run. First of all, navigate to our website, and then let's take a look at dependencies. You're going to need a JDK installed, and I recommend you to install it using SDK-man. It's pretty nice and allows you to manage all the JDK installations you have. And then for this example, you're going to need a GitHub account to log into mcp.run. And then we're going to use for this example OpenAI. So you also need an OpenAI account and an OpenAI API key. Now, the code remains pretty much the same for all the different backends that are supported for LangChain4j, except you might need to modify and adapt a little bit your Java code to configure the right model. As you can see, you will basically need to configure your Maven dependencies. You'll need an API key if you're using an online model such as OpenAI, and then you'll configure programmatically the model and plug it into the chat interface. If you're using a local model or your self-hosted service for survey models, such as Ollama, you won't need to configure API keys, but you might need to configure, for instance, the URL of the server and other parameters. This example will focus on OpenAI because it's most straightforward to configure, but online you will also find how to configure it for Ollama, and you'll see that it's pretty much the same. First of all, let's make sure you're logged into mcp.run using the ncpx tool and the gen session command. This will open a browser window and will let you authenticate to mcp.run. Once you approve the login, you will navigate back to your terminal window and you will have your API key. For this example, you will also have to install two servlets. In order to install the servlets, you navigate to ncp.run, navigate to the servlets you want to use, in our case fetch, you push the button install, give the permissions, and just save it. In my case, I've already installed them. You will need these two. All right, then you should create Java project using your favorite build tool, and obviously you can use any JVM language. In our case, we are using Maven and Java. We have installed locally the core library for mcpx4j, so we're going to use 999 snapshot, but in your case you can also depend on it from a Maven repo. Currently, the mcpx4j library is hosted through Jetpack, so you will need to configure the Maven repo so the Jetpack is available. Don't worry, it's not complicated. You just need to add a few lines, and then you can just point to it like this. For this example, we're also using small write config so that it is possible to look up values both from a config file and from variables, but you can use whatever configuration system you want. You can also avoid using a configuration system for the purpose of the demo. It's not relevant, and obviously you're going to need to depend on LangChain4j and LangChain4j OpenAI if you're using OpenAI. So we decided to use an application.properties config file, which will be then parsed by smallWrite config. So this is the contents of the config file. We have an API key property, a base URL property, which is not necessary to make explicit, but we'll use in this case. This is useful if you are pointing to local installs and mock for testing, but in general, you can just leave the default. The profile ID is usually just default, and then you will also have a config key to expose the OpenAI API key. LangChain4j exposes tools through an interface that's called ToolExecutor, which exposes this method. So we're going to implement this interface by wrapping one of the core component of mcp.x4j, which is called ncpx tool. So our implementation will be essentially an ncpx tool executor that implements ToolExecutor, wraps our ncpx tool, and exposes the right method. All it will do is logging the call, well, just for, so that we know what's happening under the hood. But then all it's doing is really just adapting the format of the message to what our internal implementation expects. And this is the ncpx tool interface. In this case, for the purpose of this demo, we're just using a string, but you can do whatever validation you feel like it's worth doing. We can now define our main. As you can see, we are parsing our config using small right config, which will look automatically for application.properties, and then it will read the values, looking up also in the environment variables if available. We instantiate our mcpx client library using our API key and the base URL, which you can omit if you want, and then you use the default profile ID to refresh the installations. We refresh the installations of our tools only once at the beginning and startup of our application, but you can also schedule this method for execution periodically so that you can refresh the installations every once in a while. For the purpose of this demo, it's not necessary, but just know that this is a thread-safe method, so feel free to call it from a scheduler. Then we fetch our servlets, and then we convert them into the format that LangChain4j expects. LangChain4j expects this pair. For each tool executor, it wants a tool specification. The conversion happens here in this method that I'm not going through in detail because it's not really interesting. There is also this companion and utility method here that is just doing the conversion. It's not really interesting, so I'm going to skip that. After you are all of the tools and all of the tool specs, you can configure the chat language model using your OpenAI API key, picking the model name, and then you can just build it. And then you can instantiate a chat language model with the configure the AI service using the chat language model that you've defined here. You provide the tools that you have defined here. You can pass whatever options you want, and then you can expose a very simple, in our case, a very simple chat command line interface. Notice that the chat class here that is being passed is actually a class that we are defining here. It's an interface that exposes the send method, and this is where also you will define your system prompt. The system prompt is the one that's provided in the tutorial. And it's the one that we figured out works better with OpenAI. All right, let's open our command line interface, our terminal. Make sure that you export your variables if you decided to use this config system. So export mcp.run API key and OpenAI API key if you want to use those. And then we can invoke our main entry point by name using the exec Java plugin. So this will start our chat system, and as you can see, there's a prompt here, and we're gonna send in we're gonna use the prompt example that we have in the tutorial. So what this will do, it will try to ask the AI to figure out what will happen by passing the string hello mcp.run into a hash function in this gist. This hash function is actually defined in C, so the LLM should figure out that it should be translated into JS and then use the eval.js servlet to do the actual evaluation. So let's try and see if it actually works. There we go. I pasted the message here, and let's see. as you can see, there's some logging, so it's actually fetching with these arguments. It's invoking the fetch tool with these arguments, and then it's invoking the eval.js with this argument, which is our hash function. And the assistant told us that it retrieved the DJB2 hash function from the provided link. This is the C code. Then it implemented the JavaScript equivalent, passed the value in, and as you can see, the value corresponds to the one that we expected in the tutorial. So it actually worked, or so it seems. All right. On the GitHub repo, you will also find an equivalent example for Ollama. The only things that change are the config, which is pretty much the same, except we don't have the OpenAI key here. The dependencies will be different because instead of depending on OpenAI, we're going to depend on the Ollama adapter. And then the main code will be different just in the config part, because here we're going to pass in an Ollama chat model builder. Here we're going to also pass a model name. Your mileage might vary depending on the model you're going to use. Llama 3.2 works pretty well with tools, and it fits on a developer machine, not too big, with not too much RAM. So it should work on your machine, but it might be less smart at figuring out how to thread together tools than OpenAI. That's just expected. But it will work. The wiring and calling on tools will just work just the same. So thanks for watching, and have fun with mcp.run.